Hi LEGO fans, I'm back with the latest set from LEGO Ideas, and this one is quite literally out of this world. Today I'm going to be unboxing, speed building and reviewing set number 21321, International Space Station from LEGO Ideas. This is set number 29 from LEGO Ideas, formerly known as LEGO Cuzo. These sets are based on fan submissions, and we've seen a number of space related LEGO Ideas sets before. Released in 2012, LEGO Ideas number 2 was Asteroid Exploration Spacecraft Hayabusa. Number 5 from January 2014 was Mars Science Laboratory Curiosity Rover. And that was followed up in August 2014 with number 7, the Exosuit. You could argue that WALL-E was loosely based on space, and the same goes for Doctor Who. But the next true space build from LEGO Ideas was the magnificent Apollo 11 Saturn V, which was released in 2017. Set number 19 was Women of NASA from November 2017. And that brings us to set number 29, the International Space Station. This was submitted by fan designer Christoph Ruge from Germany. It was actually rejected by the LEGO Ideas panel after receiving 10,000 votes. But the LEGO Ideas panel threw a lifeline to a bunch of rejected but popular ideas, and this one won the public vote, being turned into an official LEGO set. This 864 piece set retails for about $70 and is reassuringly heavy for the price point. It feels like we're getting some value for money here. Recommended for builders aged 16 plus, this recreates the magnificent ISS. The ISS program is a joint project between 5 participating space agencies. NASA from the United States, Roscosmos from Russia, JAXA from Japan, ESA from Europe, and CSA from Canada. As well as the International Space Station, we also get a small-scale version of the Space Shuttle. Given that the last Space Shuttle mission was on July 8th, 2011, I think there is some nostalgia involved here. Also on the front of the box we have the dimensions of the completed set. The International Space Station is 49cm or 19.3 inches wide, and 31cm or 12.2 inches tall. Over on the back of the box we get a better idea of what to expect from the completed model. The ISS can be mounted on a custom built display stand complete with microfigure astronauts. It comes complete with an extensive solar array, and you can use a brick-built version of Canadarm2 to dock with various service modules. Accommodation for humans is a relatively small part of the ISS, but you can see here we have various modules attached to the side. We also have a reminder that the ISS has reached 20 years old. The first ISS component was launched in 1998, with long-term residents arriving on the 2nd of November 2000. Not that we need any encouragement to buy a cool set like this, but LEGO did include a free gift for VIP members. We got this rather nice looking box, and inside it an International Space Station patch. I've no idea what I'm going to do with this, so I'm just going to put it back in the box and forget about it. It's almost time to get building, but before we do, let's open up this box and see what we got inside. Here's everything that came inside the box. We've got 6 numbered bags of LEGO containing 864 pieces, and a 143-page instruction booklet, which also includes information about the International Space Station and fan designer Christoph Ruge. I think I might have pronounced his name wrong earlier. I'm going to go ahead and build set number 21321, the International Space Station, and today this is going to be a 90-second speed build. And here is the completed 21321 International Space Station from LEGO Ideas. Today's build time was 1 hour and 50 minutes, and whilst it was quite fiddly, I don't think it really deserved the 16+ age recommendation. I do often wonder if LEGO does that just to encourage the adult fans to buy. I usually film these videos against a white background, but I noticed that some of the speed build footage looked washed out. Hopefully with a black backdrop you can see it more clearly, and I just thought it might look cool, like it's in space or something. This is very low tech, and I actually have the ISS stood on a stack of vintage LEGO Technic wheels. If you recognise these bad boys, do be sure to shout them out in the comments. For the relatively modest $70 price point, this is a very impressive looking set, not least because of that half-metre wide solar array. Each one of the solar panels is a printed part, and we get a lot of them. For example, we get 64 of the 1x4 solar panel printed tiles. That should keep the Bricklink people interested. The display stand is sturdy and decorative without taking away from the visual appeal of the overall ISS build. As this is clearly built as a display piece and also a conversation piece, there is a decorative printed tile attached to the base which explains what this is. We also have some of these microfigure astronauts which were also included with the Saturn V model. Although the parts inventory calls for 2 of these, we do actually get a spare, which is really nice. Also attached to the display stand is one of these things. I'm not sure if this is meant to be a Soyuz capsule or maybe a cargo vehicle or a service module. Certainly a Soyuz capsule is docked with the ISS at all times for emergencies. The Soyuz is also the only way to get passengers to and from the ISS at present. It costs an eye-watering $81 million a seat to take a round trip to the International Space Station using a Soyuz capsule. That's why both Boeing and SpaceX are working on alternatives for manned spaceflight. Their solutions should be ready soon and will bring the cost down to about $58 million a seat. Around the other side of the stand we have what was described in the designer's video as a transport capsule. I'm not sure if that means this is a Soyuz capsule, but there you go, that's a thing. Mounted in the centre of the display stand is a beloved old friend. Yes, it's the now defunct Space Shuttle. Although no longer used, the Space Shuttle was instrumental in assembling the ISS. It was a large reusable vehicle with a huge cargo bay. Coupled with that cargo bay, we also had Canadarm1. This was a solution invented by the Canadians for manipulating large objects in space. It paired perfectly with the Space Shuttle and was used extensively when building the ISS. The Space Shuttle is a nice but not particularly detailed build. It definitely resembles the shape of the Space Shuttle, and we've got all of the key elements. We have the flight deck up front, we have the nose cone, and you can see the leading edge of the wings here with the protective tiles, or certainly a resemblance of the protective tiles. Around the back we have the main engines or the main rocket boosters and the tail there, because this thing would pretty much glide like a plane as it came into land after a mission. Over on the reverse, on the bottom here, we've got lots of sliders which kind of represent the tiles on the bottom, the heat resistant tiles which allowed the shuttle to gain entry back into the atmosphere and allowed it to be reused again, although a lot of these tiles were replaced between missions. It's a really nice little thing, maybe not the most detailed model in the world, but it is recognisably the Space Shuttle. The stand does a good job of supporting the ISS without taking away from the elegance of the build. It's pretty sturdy, and the studs on top of the stand connect to the anti-studs on the bottom of the model. You can remove the ISS from the stand, but I wouldn't really recommend it. When I'm working with a model like this, I always find it fascinating to watch the LEGO designers video on YouTube. It's always cool to hear what inspires them and to learn about the design challenges of bringing a model like this to life. In this case, I believe this solar array was one of the bigger challenges. The International Space Station weighs 925,335 pounds. That's not a problem in the weightless vacuum of space, but it does create some design challenges here on Earth. One of the really neat features about the ISS is the adjustable solar array. Each bank of panels can be angled to face the sun, or in this case the studio lights. If you angle each of the panels just right, the effect is quite literally dazzling. Each panel can rotate around the vertical axis, and can even rotate through 360 degrees around the horizontal axis. Although the designers worked hard to mitigate this, we do have the inevitable drooping due to gravity. Each arm of the solar array uses a clever combination of ball joint and brackets to hold those arms rigidly in place. It does a pretty good job, and I'm sure mine would have looked a lot more droopy than this. Given that it costs about $10,000 to put a pound of payload into Earth's orbit, the solar arrays on the ISS are mounted on a lightweight lattice material. In the case of the LEGO model, the build has to be a little bit more sturdy, and we just have this lattice fence panel. It gives you a sense of how the ISS was built without the structural nightmares. The use of orange base plates on the solar array is certainly an interesting colour, but when you angle this to view it from the front, the colour choice is perfect. For comparison, this is the real ISS and this is the LEGO model. On the back of the array you'll notice some white fins. I believe these are part of the external active thermal control system. This system helps the ISS to dissipate heat when the environmental heat loads exceed the capabilities of the passive thermal control system. Assuming I'm interpreting the schematic I downloaded from NASA correctly, these wavy structures at the back of the ISS are used to dissipate heat also. These are described by NASA as thermal radiators. There are both active and passive heat management systems aboard the ISS. Exterior surface temperatures can range from 250 degrees Fahrenheit on the sunny side to negative 250 degrees on the shady side. That's a range of 121 degrees C to negative 157 degrees C. Communications are very important, and you'll notice a number of aerials on top and also underneath the ISS. These are really neat, especially with the combination of metallic silver satellite dish and metallic gold ski pole. In fact, you can talk to the ISS using some basic ham communications equipment. There's a program which allows children to communicate with astronauts on board the ISS. It uses basic radio signals in about the 145 MHz range, and communication sessions are limited to about 10 minutes while the ISS passes overhead. As a bonus fact, the ISS is visible from Earth. Orbiting the Earth at 17,150 miles per hour, the space station completes a revolution every 92 minutes. If the ISS happens to pass overhead at dawn or dusk, you may be able to see a bright light moving slowly across the sky. It's the third brightest object you can see from Earth, and if you go to spotthestation.nasa.gov, you can find out exactly when the ISS will be passing over you. Like many of the best LEGO sets, the International Space Station is very much a modular build. It consists of many habitation, scientific and support modules. I'm no rocket scientist or space expert, but I'm going to try and point out the things that I can recognise. The small modules you see at the end here are most likely to be Russian-built Progress cargo vehicles. I'm not sure if the black spheres are meant to be pressurised mating adapters or if they're part of the actual spacecraft. Chances are I'm wrong, but based on the cheat sheet that I downloaded from NASA, I'm going to go with the fact that they're part of the spacecraft. The larger module in the middle with folding solar panels is likely to be Zarya. This was the very first module to be put into orbit and allows Progress cargo vehicles to dock with the ISS. Beyond Zarya, things get a little bit hazy. There's another module complete with solar panels, and for the purposes of this exercise I'm going to call it the airlock. I'm probably wrong, but I'm a LEGO guy, not a space guy. Mounted underneath we have some more cargo modules, service modules, or possibly an escaped Soyuz. Beyond the supposed airlock we get to some of the more interesting parts of the space station. The interesting white bulbous object is the Bigelow Expandable Activity Module, or BEAM. This is an experimental expandable module which could be used for habitats in the future. The interesting thing on top with all of the aerials is the ITS-Z1, or Integrated Truss Structure. This is used for mounting various unpressurized components which can live outside of the space station. In between all of this high-tech goodness you'll find Node 1, or Unity, which is about 18 feet long. It was manufactured by Boeing and it joins together the US and Soviet components of the station. It's also where the crew on board get together to eat meals. Attached to Node 1 you'll find a giant can of Coke. No, seriously, that printed part is meant to be the top of a drinks can. In this case it's going to be the airlock, presumably where the crew exit the ISS to do maintenance work. Swinging back around you'll see the Bigelow Expandable Activity Module again, and this is connected to Node 3, otherwise known as Tranquility. It contains environmental control systems, life support systems, the toilet, exercise equipment, and an observation cupola. The observation cupola was commissioned by the ESA and the Italian Space Agency and gives unparalleled views of the planet Earth. It's basically a series of windows with very fine optical glass which enables you to have a fantastic viewpoint of the planet. There are lots of ways to dock aircraft and other modules with the ISS, and I believe this is going to be one of those. The black cone you see before you is known as a pressurized mating adapter, or PMA. Connected to the forward side of Tranquility is the Leonardo Permanent Multipurpose Module, or PMM. It was flown to the ISS aboard STS-133 in February 2011 and installed on March the 1st. Leonardo is used for storage of spares, supplies and waste on the ISS. Turning our attention to the front of the ISS, we have even more modules. This is the Columbus Science Laboratory, which is the largest single contribution to the ISS made by the European Space Agency, or ESA. It accommodates 10 active International Standard Payload racks, or ISPRs, for science payloads. Protruding from beneath the US-built truss segments is Destiny, also known as the US Lab. Destiny has a mass of 14,515 kilograms, or 32,000 pounds. The module that joins the US Lab Destiny, the European Lab Columbus, and the Japanese experimental module is known as Node 2. Well, to tell the truth, it's better known as Harmony, which is a much more catchy name. Node 2, or Harmony, is the utility hub of the ISS. This also provides electrical power, electronic data, and sleeping cabins for 4 of the 6 crew. Also located on the Harmony module, you'll find Pressurized Mating Adapter 2, which was built by the USA. The remaining ISS modules you see here form the Japanese Experiment Module, or GEM. This is also nicknamed Kibo, which is Japanese for hope. The large cylindrical module is the core component of GEM and forms the pressurized module. It contains 23 International Standard Payload racks, 10 of which are dedicated to science experiments, while the remaining 13 are dedicated to Kibo's systems and storage. Mounted on top, we have the GEM pressurized section, which adds some capacity. This also has a rather nice printed piece which looks like an airlock but isn't. The airlock is actually mounted on the side and provides access to the GEM exposed facility. This allows scientists to conduct experiments in the harsh environment of space. To minimise the need to go outside, there is a robotic arm known as the GEM Remote Manipulator System. Although it looks tiny here, the GEM Remote Manipulator System is actually 32.5 feet or 10 meters long. And then we come to the GEM Exposed Facility, which is made out of LEGO roller skates. The GEM Exposed Facility, also known as GEM's back porch or terrace, is an unpressurized pallet structure. Experiments here are directly exposed to the environment of space. Not all of the modules listed on the schematic are downloaded from NASA appear to be on the space station. For example, mounted on the top of Harmony should be the Centrifuge Accommodation Module. This would have allowed for experimentation in space using an artificial gravity solution. Although the Centrifuge Accommodation Module never made it to space, it is on display at an outdoor exhibit at the Tsukuba Space Center in Japan. Other notable features of the ISS include Canadarm2, which is the Space Station Remote Manipulator System. This is a more advanced version of Canadarm1 that was used on board the Space Shuttle. Mounted above and below the main truss sections of the ISS, we have express logistics carriers. This is ELC-1, ELC-2, ELC-3, and ELC-4. These provide mechanical mounting surfaces, electrical power, and command and data handling services for orbital replacement units. They're also useful for mounting science experiments on the ISS. Also mounted on top of the ISS is the Alpha Magnetic Spectrometer, which is a particle physics experiment module. This analyses cosmic ray events to better understand the origin of the universe. For a simple LEGO review video, this got very in-depth very quickly. Hopefully I didn't make too many mistakes, and I'd like to thank NASA and Wikipedia for the vast amount of information out there. Also, is it just me, or are those solar arrays getting droopier and droopier? So that was set number 21321, the International Space Station from LEGO Ideas. I really enjoyed building this set, but it was also a great excuse to go and learn more about the International Space Station. I've no doubt I've made a ton of mistakes here, but please feel free to shout them out in the comments. It was definitely a fiddly build, but I wouldn't be put off by that 16+ age recommendation. I would think older kids could get along with this just fine, especially if they've got a particular interest in space. I thought the price point at $70 was pretty good considering the amount of detail and the 864 piece part count. So if you're a fan of LEGO or a fan of space stuff, this definitely gets my top recommendation. Just be mindful that this is half a meter long and it's going to take up some room. I really hope you enjoyed my LEGO Ideas ISS unboxing, speed build and review video. If you did, a thumbs up is always appreciated, and don't forget to subscribe for more awesome LEGO content. Thanks a million for checking out today's review of the International Space Station. Stay safe, and we'll see you on the next build video.